welcome to the Docker tutorial for beginners. Docker allows you to package an application with all of its dependencies into a standardized unit for software development. Today, for millions of developers, Docker is the standard for creating and sharing containerized apps both on the desktop and in the cloud. Docker gives developers the freedom to innovate by streamlining and speeding up the workflow while allowing them to choose the tools, application stacks, and deployment environments that work best for each project. By the end of this video, we'll have a great understanding of the main Docker concepts and how Docker is used in the software development lifecycle. I, Maria from Edureka, will take you through this tutorial. In this video, I will give an overview of Docker. Then I will discuss some problems solved by the Docker containers. Then we'll explore some important components of Docker such as Docker files, images, etc. We will discuss the differences between virtual machines and containers. I will also describe the architecture of Docker and discuss how companies are using Docker. In the second section, I will include a demo of the installation, explore some common commands used, and finally end with building and pushing a Docker image to the Docker Hub. Before we get started with the topic, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content by Edureka. Also, visit the Edureka website for training and certification courses, the link to which is in the description box below. Docker is a platform and set of tools designed to simplify the development and deployment of applications by using containers. Containers are lightweight and portable environments that package an application and its dependencies together, allowing them to run consistently across different computing environments. With the help of containers, programs can be logically packaged and separated from the actual environment in which they operate. So this decoupling makes it possible to deploy container-based apps consistently and with ease, regardless of the target environment. This makes it possible for developers to design dependable environments that are portable and isolated from other applications. Docker is extensively utilized for software development and deployment because it simplifies the process of packaging and running applications, streamlining the development to deployment workflow. It has become a fundamental tool in the world of containerization, helping developers and operations team achieve greater consistency and efficiency in managing their applications. Docker is a containerization platform that solves several problems in software development and deployment. Some of the key problems it addresses include portability of software. Docker containers are lightweight and can run on any system that supports Docker, regardless of the underlying infrastructure. This makes it easy to move applications such as development, testing, and production between different environments. Dependency management. Docker allows developers to package applications along with all their dependencies into a single container. This ensures that the application runs uniformly across multiple environments. Isolation. Docker containers provide process and resource isolation. This means that you can run multiple containers on the same host without them interfering with each other. Scalability. Docker makes it straightforward to scale applications horizontally by spinning up new containers as needed. This is essential for handling increased loads and ensuring high availability. Resource efficiency. Docker containers share the host OS kernel, which reduces the overhead of running multiple virtual machines. This leads to more efficient resource utilization, making it possible to run more containers on a single host. Protection against virus. Every time we install and run new software on our computer, we are risking the security of our computer. Containerizing the software helps us mitigate that risk. What this means is that the scope of any security threat associated with running a particular software is limited to inside the container. So before exploring the architecture of Docker, I will discuss some of its key components. Docker Engine is a central component of Docker. It's responsible for creating and managing containers on a host system. It includes a server, an API, and a command line interface for interacting with containers. Containers are instances of Docker images that run as isolated, lightweight environments on a host system. They provide a consistent and predictable runtime for applications. On a particular host, you can run multiple containers at once thanks to the isolation and security. Docker Hub. Docker Hub is a cloud-based registry. It allows users to share and distribute container images. It's a repository for Docker images, and it provides a platform for sharing and working together on containerized applications. Docker Compose is a tool for creating and executing multi-container applications. It uses a YAML file to specify the services, networks, and volumes required for an application, making it easier to manage complex applications that consist of multiple containers. Dockerfile, a text file with building instructions for a Docker image, is called a Dockerfile. It details the software installation, configuration settings, base image, and environment variables required to build a container. Docker image, an executable package that runs independently and includes an application along with all of its dependencies, is called a Docker image. Images are used as the building blocks for containers and can be shared and reused. Now, since you have an idea about Docker components, you might be thinking about how virtual machines are different from containers. Containers and virtual machines are both technologies used for virtualization, but they operate at different levels of software stack and have distinct characteristics. Here are the key differences between containers and virtual machines. Containers operate at the application layer. They encapsulate an application and its dependencies, including libraries and binaries, into a single unit. Virtual machines operate at the hardware layer. Each VM includes a full operating system, and multiple VMs run on an hypervisor, which emulates the underlying hardware. Containers share the host operating system's kernel, making it more lightweight and efficient in terms of resource utilization. Containers start quickly and consume fewer resources than VMs. Virtual machine. Each virtual machine requires a separate operating system instance, leading to higher resource overhead. VMs generally have longer startup times compared to containers. Containers are highly portable. A containerized application and its dependencies can run consistently across different environments as long as the host has the necessary container runtime. Virtual machines are portable to some extent, but migrating VMs between different hypervisors or cloud providers can be more challenging due to dependencies on specific virtualization technologies. Containers generally have lower overhead and better performance compared to VMs because they share the host OS kernel. Virtual machines have higher resource overhead due to the need for a complete guest OS for each VM. Scaling is simpler with containers. Microservices architectures and dynamic workloads are ideal for containers because of their rapid start and stop capabilities. Virtual machines can be more resource intensive to scale since each VM requires a full OS instance. Docker architecture. The Docker architecture is based on a client-server model and consists of several components that work together to enable containerization. The Docker client is the first component of a Docker architecture. The Docker client is a primary way that Docker users interact with Docker. The command line tool that lets users communicate with the Docker daemon is called the Docker client. Users can use the Docker client to build, manage, and interact with containers and Docker images. We can run commands such as docker build, docker run, and docker pull in the Docker client. So the Docker host is the second component of the Docker architecture. It comprises the Docker daemon, images, containers, networks, and storage. The Docker daemon, also known as the Docker engine, is the background service that runs on the host system. A REST API is used by the Docker client and daemon to communicate over a network interface or Unix sockets. The Docker daemon listens for Docker API requests and communicates with the host kernel to manage containers, volumes, images, and networks. Multiple daemons can be communicating with the Docker client. And the Docker registry is the third component of the Docker architecture. The Docker registry contains all of the Docker images. Docker Hub is a public registry of Docker. The use of Docker registries facilitates the distribution and sharing of Docker images. With the help of Docker run or Docker pull commands, we can pull the required images from our configured registries. Companies using Docker. Multiple leading companies use Docker in their operations. These include Google. Docker is widely used within Google, and the company has been a significant contributor to containerization technologies. Google also developed Kubernetes, an open source container orchestration platform that works seamlessly with Docker. Microsoft. Microsoft has integrated Docker into its Azure cloud platform. Azure Container Instances and Azure Kubernetes Service are examples of Microsoft services that leverage Docker containers. AWS. AWS provides container services like Amazon ECS, Elastic Container Service, and Amazon EKS, Elastic Kubernetes Service that supports Docker containers. Facebook. Facebook has utilized Docker for various purposes, including managing and deploying applications in its infrastructure. Netflix. Netflix has incorporated Docker into its microservices architecture to enhance the deployment and scalability of its streaming services. So these examples showcase the broad adoption of Docker across various industries. But Docker is not limited to these companies, and many others, including startups and enterprises in various sectors, have embraced containerization for its benefits in terms of portability, scalability, and consistency. Now, let's move ahead with the installation of Docker Desktop in Windows. So go to the web browser and type Docker Desktop. Open the official Docker website and click on Developers. So you'll have an option Docs. Click on that. Now we have Download and Install. Click on that. Now we have Docker Desktop for Mac, Docker Desktop for Windows, as well as for Linux. So now in this video, we are concentrating on Docker Desktop for Windows. So click on that. Yeah. So before installing the installer, just go ahead and take a look at the system requirements. So WSL version is to be downloaded. So open your command prompt and type WSL install. Yeah, so I've already installed WSL. WSL is nothing but Windows subsystem for Linux. So I've installed it. So I am getting Ubuntu is already installed and it's launching Ubuntu right now. Okay, so now you can see that it is done. And another thing that you need to make sure is that you need to go to the search bar and type Windows, turn Windows features on or off option. Okay, open that and then you will get a window like this. Here you need to make sure that you have enabled Hyper-V. Okay, this is Hyper-V. This one is Hyper-V, as well as Windows subsystem for Linux, this one. Okay, once you are done with all this, you can go back to the install Docker Desktop on Windows. You can go back to the system requirements and here you can see the hardware prerequisites required. Here we need 64-bit processor, 4 GB system RAM, as well as virtualization to be enabled. Yeah, so once that is done, you can go ahead and click on Docker Desktop for Windows. That time your installer will be downloaded, and once the installer is downloaded, open the file and enter the basic credentials required. So it will take a few minutes and you will get a prompt to set the configuration. Make sure that the default options are set. And finally, we'll have to restart the system to complete the installation. After the installation, go to the search bar and type Docker. You can see that Docker Desktop is installed in our system. You can go ahead and open it. Yeah, so this is the Docker Desktop. Now you can see these are containers. Here the containers that we create will be showed up here, but here now we don't have any containers and the images will be displayed here. So this shows us that Docker Desktop is installed And to confirm it again, you can go to the command prompt and type Docker. Yeah, so this is also a confirmation that Docker is installed in your system. Now that you have installed Docker in your system, let's move ahead and explore some basic commands in Docker. Go to the command prompt and type Docker run hello world. Yeah, so now you can see hello from Docker. This shows that the installation is working correctly. Next, type Docker version. Yeah, this is the Docker version. The Docker version is 24.06. Once that is done, go ahead and type Docker pull and the image name. Okay, here I am giving Ubuntu as the image. This command is used to pull images from the Docker repository. Yeah, now you can see the pull command fetches the Ubuntu image from the Docker registry and saves it to our system. Now, Docker run d and the image name. So this command is used to create a container from an image. So when you call run, the Docker client finds the image, here Ubuntu, loads up the container and then runs a command in that container. Now Docker ps. Here this command is used to list all the running containers. Docker ps a. This command is used to show all the running and exited containers. Okay, this command, which is docker exec it, copy the container ID that we had created, yeah, and bash. Yeah, so now this command is used to access the running container. Now you can see that we are inside the Ubuntu terminal. Okay, so we'll exit. Yeah, then you can type docker login. This command is used to log in to the Docker Hub repository. Okay, so I've already logged in, but you will be asked to enter the username and password before logging in to the Docker Hub repository. Next, Docker images. Yeah, this command lists all the locally stored Docker images. Docker stop and the container ID. So this is the container ID. Let's copy that and paste it here. Docker stop the container ID. So this command stops a running container. Yeah, so the container is stopped right now. Next, Docker rm and the container ID. Yeah. So Docker rm command is used to delete a stopped container. Next, we have Docker kill and the container ID. So we use this command to stop its execution immediately. So difference between Docker kill and Docker stop is Docker stop gives the container time to shut down gracefully. So in situations when it is taking too much time to get the container to stop, one can opt to kill it. Great. So now as we got the hang of some Docker commands, we will move ahead and create a new Docker image, run it as a container and push it to the Docker Hub. Here, we are going to look at how we can run a dead simple static website. We are going to pull the Docker image that we create from the Docker Hub, run the container and see how easy it is to run a web server. First of all, you need to open a new tab and type Docker Hub. Yeah, open the official Docker Hub website. Yeah, and you need to sign in. So I've already signed in and here this is the explore option from the Docker Hub website. So here you can see many images that we can use. And then we have repositories also in the Docker Hub. So these are my repositories. Alright, so once you create an account here, what you need to do is go to the command prompt and type mkdir static site. Okay, so we are making a new directory in the So we are making a new directory called static site. Yeah, now change the directory. So here we use Nginx to host the simple static content. So Nginx is an open source reverse proxy server for HTTP, HTTPS, SMTP, as well as load balancer, HTTP cache, and a web server. So what we have to do right now is we need to create the Docker file in the directory that we have created. So this is the directory. So go ahead and this is my directory static site. Okay. So open the notepad and type this command from Nginx copy index.html user share Nginx HTML. Okay. So the official Nginx image has a specific path where it looks for files. So you can either copy a file into the image this way. So here, this index.html is the HTML file that we are going to create. Okay, now we need to save this Docker file. Okay, so we need to save this Docker file in the directory that we have already created and save it as capital DOCKER file, and save as type should be given all files. Okay, then you can save it. Yeah, so now we have created our Docker file. Let's go ahead and create the HTML file. So this is the HTML file, index.html. So this is a simple static file that I have created for the sake of this demo. Now you need to save this also to the directory that we have created, static site. Okay, save it as index and save it as all files, index.html. Okay. Yeah. Now we can see there are two files, Docker file and the HTML file in the static site that we have created. Next, go to the command prompt and type docker build -f dockerfile.txt -t. Maria David is my username. My Nginx image 1 v1. Alright, so here Maria David is my Docker Hub username. Make sure you replace it with yours. And my Nginx image 1 is the image name. Okay, and also don't forget to type a full stop in the end. Alright. Yeah, now we have built the Docker image. Next, let's run it using the docker run command. Docker run name my Nginx 1. 8080 is the port D and it is the username. Okay, we are running the my Nginx image that we have created. So the web server will be launched in this port, that is 80. And Maria David, as I said, is my username. Okay, Docker Hub username, and this is the image that we have created. Yeah, so now let's check using the Docker images command if our image is present. Yeah, so you can see the first image is what we have created. Next, let's push this image that we have created to the repository, that is the Docker Hub. So using the docker push command. Yeah, so now that is done. Now we need to go to the Docker Hub repository. So this is the Docker Hub repository, and now you can see this is the image that we have created and it is being pushed to the Docker Hub. Now go to the Docker desktop. Now we can see that the image that we have created is present here. Now let's go to containers. Yeah, now this is the image that we have created and it shows that it's running and it's running in this port. So let's click on that. Yeah, so now this is the static website that we have created and it's being successfully displayed in the local host. So this is how we create an image, push it to the Docker Hub and run the web server inside a Docker image. Docker simplifies the development and deployment processes by providing a consistent environment across different stages of the application lifecycle. It has gained widespread adoption in the software development and IT communities for its ability to enhance collaboration, scalability, and reproducibility in application development. Now, since Docker is installed in your system and you have an idea about Docker commands, go ahead and explore the containers, images, and start running your own applications in Docker. I hope you got an idea about Docker. So if you got an idea about Docker, please consider subscribing to our YouTube channel. Thank you for watching and keep learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!